Welcome back. In this video, we'll get the camera controller working. Although first thing, let's make this ball a little bit snappier in terms of the movement. And what we're just going to do is multiply it by a speed factor. So pretty straightforward here. Now I'm going to come up over here. Now, one thing I didn't mention was the idea of being public or private. By default, everything would be public, or sorry, be private. And so just to make it visible, I'm going to set that to be public. And that will just help me explain one thing. I'm also going to set this to public. Probably don't need to, but for our purposes, that's fine. And we're going to use a float. It's going to be potentially a decimal number, and I'll call it speed. Now, what I'm going to do is I'm going to set that speed to default to 1. And we have to put an F at the end to indicate that it's a float rather than a double, but that will be okay. Now, just to show you about that little idea, save it. Come back to Unity. Anything that you set as public will be visible in the inspector. Now, it also means that you can modify it. Other scripts can modify it, but we won't worry too much about that right now. But you can see here, we've got RB, there's the rigid body, and the speed is set to 1. Now, if I run this, what happens when we saw that get component, it will actually grab that rigid body and put it sort of in here. So when I hit play, it runs that start part of the script, and then you can see that it's found the player's rigid body. Okay, now we haven't changed this value, and even if I did, it wouldn't affect the speed because we actually haven't used the value in our code. So I'm going to come back down here, and all we're going to do is we're going to kind of multiply this force in a way. So the movement's going to have, sort of a greater effect. So I'm just going to times it by the speed. And I think, what I have to do is put that into the movement there. So basically, if we times it by 2, there'll be twice the amount of force. Okay, times it by 10, it'll be 10 times the amount of force. So you just have to find which one works best for you. So again, make sure you save, and you can see you get into this habit. Usually I use Control S, but I'm just using the button there to remind you and remind myself. And now when we come down to here with the player script, if I press play, first of all, there should be no errors. But obviously, like I said, it's not going to be any snappier. If I what I usually do is, well, I'll show you what happens. If I do change it here, so it says put it to, not to 0, but to 10. If I press it to 0, it would actually stop. If I set it to 10, you can now feel that it's a much snappier and easier to control. And I think probably 10 is about the right number. I mean, you can experiment, right? Try 1,000 and see what happens. But yeah, I think 10 is a good number. Now what happens here, I'll try to stop it for going off the world. It will say 10, but when I stop, it goes back to 1. So there is a way to prevent that from happening. I can't quite remember at the moment, but you just have to remember that if you're in play mode, those changes will not be set. Okay, so now we got a snappier ball. What we want to do is make sure that the camera can sort of follow that ball. Now, first thing what I'm going to do is you can, and usually there was a little window that popped up here. When you clicked on the camera. That doesn't seem to be on mine. Oh, maybe that, I need to turn this on. There we go. So there's that camera view at the moment. What I want is just to bring the camera up a little bit so you can sort of see, roughly what height would work out well. Doesn't really matter what number. I'm just going to put that was close to 4. I think that's probably good. And I'm just going to rotate it down. And I think it's on, no, not on that axis. I got to rotate on. I'm just thinking. So it's going to rotate around, I guess, yes, the x-axis there. And so we just want it pointing down a little bit. So maybe is that too much? 20, maybe like that. And then you can move, if you want, you can move that in because it was at an angle. I'm going to move it up a little bit so that we've got a little bit of a bird's eye view. We can always modify it. That's fine. So now if I hit play, we just have a bit more of a better angle to kind of see what's going on. But of course, it still can go out of frame, right? So we want that camera to be a bit more responsive and follow that ball around. So how do we do that? Well, we're going to have to add a script. Basically, a very simple camera follow script. So what I'm going to do, go back to project, into my scripts, we can add another script. So I right-click inside here, make sure you're in the scripts folder, create mono behavior script, and this time, see it's blue there, so I'm going to call this camera controller. Again, descriptive, okay? And when I double-click now, it takes me to another script, looks identical to what it did before, but we're sort of, starting fresh again. Okay, so what I'm going to do is create two variables at the top. So I always give myself a little bit of space there. Again, I'm going to set them to public just because that makes it easier for us to see. So vector3, and I'm going to call this the offset. Now the principle behind this is that the camera and the ball will always be the same distance apart. Okay, so if that's going to be the offset. So if the ball moves to left, the camera moves to left. If the ball moves forward, the camera moves forward. It's always going to sort of move in lockstep with it. It's not going to be a dynamic camera, really, but it's just going to sort of follow the ball. So we always have the same view, for better or for worse. I mean, it's for better in the sense that it's pretty easy to code. Now, it needs to follow the ball. So what we're going to do is that's a game object. Okay, so anything in our game is a game object. And give it a name. Well, it's going to follow the player. At the start, what we want to do is measure the offset. So the idea is that we've set the camera to where we want it. And so what will happen is it will basically take the position of the camera, position of the player, and then find the difference, and that will be considered the offset. And then when we do the update, well, if the ball's moved, then we can sort of have that position, right, that offset, and just add it back so that it maintains that sort of same distance from each other. So what I'm going to do is measure the offset at the start. So the offset is going to be, and I'm going to say this dot transform position. Now, this dot transform position refers to this object, which is going to be the camera controller. Okay, that's what this refers to. And then transform dot position, remember when we talked about how everything in 3D space has a position. And so what it's going to do is it's going to grab the transforms position. So this object, in this case, sorry, I should go back to the camera because it's really the camera here, the camera's transform position. Okay, and those dots you can almost think of as possessive, right? The camera's transforms position. And what we're going to do is we're going to subtract the player's transform dot position. So player dot transform dot position. So basically that measures the difference in the x, the y, and the z value. And in fact, we'll be able to see that in a second. Okay. Now, what we want, and we can do this in the update because there's no physics involved. Okay. What we want to do is basically set the camera's position to the player's new position, but keep that offset. So we're just going to sort of add to it to make that work. So let's just see here. So this dot transform dot position. Now the suggestion was just the offset, but we don't want just the offset. We want it to be the offset plus the new player's position. Okay, player dot transform dot position. There we go. Okay, so that should be good there. Now, what we're doing is we're adding vector 3s. This is a vector 3. It has an x, y, and z component, and the player's position has an x, y, and z component. So we put those together. That means we're going to sort of update the camera's position based on those two values. So let's save this. And we have to do a couple of very important things to get this working. So first off, make sure your camera is selected. Remember, the scripts in here are doing nothing until they're added to some sort of object in your game, basically. So what I'm going to do is grab this camera controller and drag it over. Okay, now here, as I was saying, the offset is a vector 3. It has x, y, and z values. It hasn't measured anything yet, so those are set to 0. Now the important thing is the player is not set. Now we also have not defined who the player is. We called it player, but the computer really doesn't know. It doesn't make that connection that we might make, right, as humans, oh, player, player. It needs to know who the player is. Now we could have done that in code, but sort of for our game, it's pretty simple. We can just drag that player in. So I could just click and drag it in. Or maybe a little easier, you click on these little sort of bullseye there, And if you don't have too many things, oh, there's player right there. Okay, so just double click on that and it knows who the player is. So now what we do, if we hit play, hopefully everything works, but the key thing to begin with is that it measures that difference. So remember before it said 0, 0, 0, now we do have values. And so what it's basically saying is that on the X value, there's zero difference. And that's because they're lined up, they're sort of centered, right? The camera, the middle of the camera lines up with the ball, okay? On the Y, well, we're pulled back a bit, right? If it was 0, we'd be right on top of it. And then the Z, we're moved up from it. So in this case, just because of the math we've done, it becomes negative, but it's just because we've subtracted one from the other, we've got a negative number, but the whole idea is that it's up above. Now the proof that this is working is that if I move to the left, you can see the camera has moved as well. If I move forward towards the camera moves back, okay? And then the camera moves, I guess the other way, backwards, forwards, whatever you want to say, in the other direction, right? So yeah, now we have a very simple camera controller. The ball moves and the camera moves. Now you can sort of see that happening. Let me just get this going. If we click on the scene, you can see there that the ball, so we're still in play mode, the ball and the camera are moving at the same time. And so, yeah, there's the same distance apart, there's the same relative positions, but obviously as the ball moves, the camera moves too. Now the question is, what happens when the ball comes off the edge? Everybody's waiting with bated breath. Look at this, it's getting closer and closer. Well, what do you think is going to happen? Well, the ball will fall and the camera will follow it. So what's kind of interesting is here, right, in the camera view, it doesn't look like it's moving because we don't have anything relative to compare it to that it's falling. But yeah, it is falling, and you can definitely see that with our y-axis, right? It's getting more and more negative. We're at now almost 20,000 unity units, and it would accelerate faster and faster as it falls. Okay, but that's good enough for here. We want to prevent that ball from falling, and so we will create some walls in the next video.